mentioned there was a subtle difference between sequences and series. Series is when we chuck the plus signs in and add them all up. So we're interested to know what that actually is. Let's look at the sum of a sequence. So the series is add them all up. So term 1 plus term 2 all the way up to term n is our sum. We can abbreviate it this way using the sigma notation, similar to what we do in stats, I guess, is one of the first times we see it, the sum of the frequency column and so on. So if we were to sum up every term going from the first term to the nth term, we would get the value of the series. So if I wanted to find this one, I could simply write every single one out and then add them all up, 45, which is good if there's a small amount. Mind you, if I've got a large amount, that could take some time, and this one's even trickier because I don't know the general term here. I know that the sum to 10 terms is 29, and the sum to 11 terms is 37. What's the 11th term? Actually, I don't need to know all the other ones, because if we create the series by just simply adding the next term on, then the difference between the sum of the 10 terms and the sum of the 11 terms must be the 11th term. We've just added it on. So I can just subtract, and so it turns out to be 8. This time we've been given a formula for the sum to n terms, and we have to find the general term. Well, I could use that same idea then. If I grabbed sum n and subtracted the one before it, so sum n minus 1, the general formula there was 5n squared minus 2. But I'll subtract, but instead of having n there, I'll have n minus 1. This should give me the general term. So let's expand out, simplify, and then we've got it. There it is, 10n minus 5. Let's look at arithmetic ones in particular. They're the ones we're interested in. I'm going to add them all up. So I've got the first term, a, then I'm going to add on the second term, a plus d, then the third term, a plus 2d, and I'm going to keep going and keep going until I get to the last term, which I'm just calling L for the last term. Well, the one before that must have been the last term minus that common difference that we've added on, and the one before that would be L minus 2 of the differences. That's so nice. I'm going to write it again, but backwards. Why do that? Well, I've created some simultaneous equations now. If I add these two things together, all of those plus d's and minus d's, plus 2d's, minus 2d's, and so on, cancel. And I'm just left with a plus l, a plus l, a plus l, a plus l. So every single term is a plus l. How many of them do we have? Well, there were n terms. So I've got n lots of a plus l. But remember, this is a simultaneous equation, so I've got 2 lots of sum to n. Divide both sides by 2, we get a formula. n on 2, a plus l, which is great if we know the last term. Now, if I don't know the last term, I can solve that problem. I'll just put in the general term for it, a plus n minus 1d, and create a new formula. And there it is. So if I don't know the last term, I can use this, as long as I know the first term and the common difference. Let's do some examples. First term is 3. The sixth term is 96. So what's the sum to 6? In this case, I know the first term. I also know the last term because they want the sum to 6 and they've told us what term 6 is. So I can use that n on 2 a plus l formula. Substituting in, and we get 297. What's the sum of the first 100 even numbers? And let's just pretend for a second that I cannot possibly work out what the 100th even number is. Not too difficult. Cannot work that out. But I know the first term's 2. And if they're even numbers, I'm going up by 2, so the common difference is 2. And there's 100 numbers, I could use the other formula. n on 2, 2a plus n minus 1d. Substitute into that one. Bit of calculation. There it is. 10,100. Sum of the first 10 numbers is 100, and the first 5 numbers is 25. So what's the first term? The common difference, and the general term as well. So what do we know? Sum to 10 was 100. That means that 10 on 2, 2a plus 9d, using that second formula we looked at, is equal to 100. Well, we can make that look a bit better. Tidy it up. 2a plus 9d is 20. Okay. Other bit of information. The sum of 5 terms is 25. Again, let's put that into the formula. Tidy it up. A plus 2D is 5. We've got simultaneous equations. I've got to find A, I've got to find D. Well, let's make the second one 2A plus 4D, so I can cancel the A's. We get 5D is 10. There's our common difference. Sub back in. First term must have been 1. We still got to find the general term though. So A plus n minus 1D gives me 1 plus n minus 1 times 2. Playing around with that one. 2n minus 1. There's the formula for this particular pattern. 2n minus 1. This is the one that appeared in last year's HSC. It's in the advanced paper, question 17. So cards are stacked to build a house of cards. And a house of cards is 3 cards basically. And there's a picture of it shown. That one's got 3 rows. So 3 cards end up in the top row because there's only 1 house of cards. Then 6 in the next row because there's 2 house of cards, and so on and so on. So we're adding 3 cards each time. We had to show that a house of cards with 12 rows would have 234 cards altogether. So the first term, well, 1 house of cards had 3 cards. We're adding 3 cards on each time, so the difference is 3. Number of rows is 12. So there's our information. Sub it into our formula. So sum to 12 would equal this particular thing. Now remember, this is a show that question. So do not be lazy. Show that means show where the answers go. Show the substitution step. That's key in a show that question. You know where the number's coming, especially when they've given you the answer is 234. If you would just go, oh, that equals 234, they're going to say, well, yeah, I told you that. You were meant to show me how you got it. So the substitution step, really important. Part B, another house of cards has a total of 828 cards. Now, how many rows were in it? So this time we know sum to n is 828. We've got to find n. We've already worked out a and d in the previous question. Substitute that in. Here's our equation we have to solve. We end up with a quadratic. What multiplies together to give minus 552 adds together to give 1. When you're doing this sort of question, there's a really quick way of finding the numbers. Because when the difference is only 1, so add together to give 1, look for the square root of that number. Square root of 552, who's got a calculator? What's the square root of 552? Okay, so 23.49. So I'm going to look for numbers around 23.4. I know it's got to be a whole number to solve this problem. Actually turns out it is 23 times 4. Negative 23 times positive 24. So when you get those small differences and you've got a really big number, just find the square root of that big number, and it's probably going to be around there. You can multiply. 2 possibilities then, negative 24 or 23. Well, one of those doesn't make sense. Remember, this is a practical question here. You're not going to have negative 24 rows. N's got to be greater than 0 for this question. That means we've got 23 rows in our house of cards. Here's one that's in sum notation. So n equals 1 to 10. There's the general term, 3n minus 6. I can find the first term, sub in 1. I can find the last term because they've told me there's 10 terms all up. And we know there's 10 terms. Let's use the A plus L formula. Subbing in, there's our answer. Just be careful when you see it in sum notation. Make sure it is starting from 1, because sometimes they might say going from n equals, or let's say 3 to 10. In that case, the first term would be when n equals 3, and you substitute that in. Now the last term would still be 10, but how many terms do you have? If you're going from 3 to 10, you don't have 10 terms now. You would have 7. So therefore, how many terms have we got? Very good. That's the point I think I was trying to get to. We've actually got 8 terms. Just don't go 10 minus 3 because we're inclusive. Both ends are included. So you'd end up with 8 terms, not 7. Okay, took me a while to get to that. Exercise 1E and 1F.